Okay. All right. So we continue now the VPN site to site, right, for the remote office, right, for over the internet. So for the backup, no. So last time, I mean, like the last lab that we already successful, we can ping the loopback between this one to with this one, right? And also we try to make a BGP crossing the loopback. I'm not sure that is a good idea or not. We're using the BGP as a source. I rather use the tunnel IP, because the purpose I use the loopback interface. Because I don't want the tunnel interface. Right, last time I remember I little bit talk about that because we don't want to use the with the internet, the IP address, because we have to do the crypto, those kind of stuff inside the tunnel interface. So maybe we use the loopback as the tunnel source and destination, and maybe make more easy. I believe so. Uh, anyway, this is just the lab, right? So we just hopefully we can make it work, right? Let's review again from last time. Can we make sure? Can we ping the IP from 192.168.253.2? Can we ping that this IP, the loopback on this MPLS router, is crossing the VPN site to site, right? Let's hop into the router first. We are in the here headquarter MPLS router. So we show IP interface brief again. You see, we have the loop back in here. So we try to ping the 53.1. So 192.168.253.1. Yep, you see, still working. Beautiful, right? It's still working. And then we go back quick here. Same thing again on the Chicago. Show IP interface brief, right? So can we ping 192, 168.253.2, the other side? Wait a second. Did I typo? Yeah, I think I got typo here. Come on. Make sure it's working here. Uh-oh. Uh-oh. Oh, wait, this one is not working here. Really? That's just interesting though. Did we miss something safe? Let me try again. The other side is working, right? You see here? So we ping. Yep. And then how about go to the MPLS router here? Oh, maybe I need to use in the source. Okay, let's bring it up again. You say source from 192, 168.253.1. Yeah, okay, so we're just using the source IP, okay? Just crossing. So now let's review from the last time. See, I show you in here. Show run section BGP. Yeah, you see, this is the BGP, right? We're using the loopback. You see, but maybe this is not good idea, right? Maybe the easy way using the tunnel. I still love the tunnel, instead the loopback. Maybe this is good also a demo to you. What is the tunnel interface? When we going to use the tunnel interface, right?
Mm-hmm.
Before we do that, just verify again. Go back to the internet router here. Just make sure do we just show here, show crypto, ICM, okay, SA. Just make sure to find out what is the status. Make sure the status is active. Yep, you see, it's still active. That's beautiful. Okay, and the same thing again. Show IP, show crypto in here. Show crypto, and then IPsec. Okay, and then SA, just to find out, make sure we got encrypted. No. Okay, and then let's see. We should be have any. This is good. Is yep. See, this already get encryption. Beautiful. Okay, so yep, it's still working fine. That's fine. That's good. Beautiful. Now let's do like this. Maybe this is good for you to demo. So let's go back to the okay. Since we're in this here, the MPS router here. First thing, let's do like this. I want to delete this one first, okay, to remove it. See, because right now it's show IPBGP summary, right? So we still have the loop back from last time, you see? We have an app in here, right? So now this is a good same thing again. demo to you how we remove the neighbor pair. So we highlight this one, you see here, then we hit enter. Now you just have to be careful. You have to put, instead you put no. I normally, for me in the production, I rather highlight this one first, you see, just like this. And then here, instead, and then I need to go back here. So this is the safe way to do it. Just make sure if this is the correct that neighbor that you want to remove from the BGP. Okay, so now we confirm it's good, and then you put no in front of it, and then you hit enter. Okay, so now you see, now we show IPBGP summary. You see, we should be gone, no more. And then we show run again section in here. You see, router BGP. Yep, you see, it's gone. No more the 192. Okay, so let's do some cleanup first. Make sure we do as well in this router, right? So show run here section again, router BGP. Okay, so now we go to complete key again. We highlight this one again, and then we hit enter. Just make sure again, we don't want to put no first in front. We just highlight this one, you see, and then move the left arrow key. All right, and then put no. Okay, just make sure everything is good. Verify, confirm. This is the neighbor that we want to remove. So hit enter. Beautiful. Right. So now we show IPBGP summary. Okay, it's no more 192 from the loopback. And then we show run again here, section see BGP, and it should be clean now. You see, the 192, right? See, being removed. Okay, so now this example for you. See, show IP interface here. Show IP interface brief, right? So now you see we have a loopback. So the loopback we want to use as the source for the tunnel, right? So now you see in here the config key. We're going to create the interface tunnel. See, this is a tunnel interface. Instead of loopback, we're using the tunnel interface. So, okay, this tunnel interface, maybe we say we want to use let's say 10, okay, like tunnel 10. You see, interface tunnel 10. In here, same thing again, we need to assign the IP address, right? You see here, do show run interface tunnel 10 first. You see, it's nothing, right? It's no IP address, you see. So now we're going to say IP address. Now, this IP address is the tunnel IP address. So now once this tunnel is up, and then we want to ping the neighbor because in the same subnet, right? So that is like tunnel is like direct connect. Okay, make it like direct connect. So now IP address in here. So let's see, we want to pick up. Let me see from 10 network, or maybe we should like demo in here for you. We totally isolate, so we can like segment out, so it's easy for you which one is the loopback, which one is the okay. In here, just quick here, we're using 172 class B network, private class B network. Okay, 162 say 16. Okay, so now we want to say for here just demo, we want to big dark 2 here. Okay, so what is the IP address in here? So okay, we want 255, dark 255, dark 232, just less 30. Okay, 2 hosts. Hit enter. So now same thing in here. We go back, same thing again. We go back to the Chicago and the Chicago here, right? We go to complete key again, same thing again. So we have to be say interface tunnel. We create interface tunnel 10. Did I spelling wrong? Okay. So now same thing again, IP address. In this case, we want to 116.1.1, 255.255.252 in here. Hit enter, right? So now do show run, you see, do show run interface 10, the tunnel 10, you see. So this is the internal IP, you see. Once the tunnel is up, we should be able to ping the other side. Okay, see here. Do show run again interface to node 10. But then it's not complete yet. the configuration of the internal interface, right? So we have to continue in here, right? So we have to be we have to be tunnel, you see. Then you put the question mark in here. See what kind of tunnel? Okay, we're looking for the source, you see, the source, right? So this is the source. You see, we put the question mark again. And then what is the source IP? So we're using the source IP, the one that we just created from the loopback. We're using the loopback 0. Okay, so we're using the loopback 0. All right. So then you can just put in here if you want to loopback 0, or you can type 192.168 if you want to more complete. You see 168.254. In here should be dark. What is the topology? Yeah, dark one. 253. 2 dark 1. You see, this is the tunnel source. Okay, so now once we have a source, now we have to, because the other side, the endpoint, right? So the destination, because it's already reachable, we know already we can ping, right? So 192.168.253.2. You see, hit enter. Okay, so this is should be like this, simple enough, right? You see, we don't need to because you see, hold on. So in here, so show IP interface brief. Okay, so now we have the tunnel here is up and up, and then we go back to here again. So the same thing again in here, the tunnel source, and then we want to use 192. This is the local, right? This is the 253.2, and then the tunnel source will be the remote loopback. Okay, the loopback is a 192.168.253.1. You see, that's it. All right. So because you don't want to specify anything, this is just basic, because everything we already covered by the IPsec from the loopback. Because we're using the source as a loopback, we should be over the internet. We already encrypted, you know. So we don't have to worry about more inside the tunnel that we want. Otherwise, you have to do like this. You see tunnel here, and then they have like a tunnel mode in here. I show you. See, then they have an IPsec. Okay, or you want the GRE tunnel, or you want the IPsec tunnel. You see. Okay, and then after that, the tunnel you have a protection. You see, because you have to select the IPsec. You see, now this is like this is configuration. The IPsec is inside with the tunnel profile. You see, with the profile. Okay, so now we're not fancy enough. Should be fine for our simple demo here for you. I just want to basic introduce now what is the tunnel interface. Okay, so now show IP interface again. Show IP interface brief. Okay, see now look at that. The tunnel is up now. Okay, so I should be able to ping the other side. See, because it's a direct connect, right? So it should be say ping duck 1. So the other side should be duck 1. Ping it. Beautiful. Look at that. And then from the other side, see here, same thing again. We should have to be able to ping the other side, that one, that 2. Beautiful. So far, so good?
Mm-hmm.
Yeah, so that's what I'm saying. This is the show run again interface, tunnel 10. So this is the demo for you. You see, we're using the tunnel, okay? The tunnel interface, create the tunnel. Okay. Okay, so now once we're able to ping, now we have to be perform again for the BGP, right? So now the BGP we should be using the tunnel interface in here. Okay, so show IP interface again here. All right. So now do show no show here again. Let me move it up a little bit here. Okay, so we should be show again here. Show run section BGP. All right. All right. So now I want to complete key. We want to router BGP 65.0.0.0.7. And then we here, so we put the neighbor now. The neighbor should be we using the tunnel interface IP, okay? 192.116.1. This is the one, the remote should be dot 2. And then what is the remote AS, right? What, let's see from here. It's a 65.0.0.3. So we're going to 65.0.0.3. Hit enter. Now you see, now we have show IPBGP. Now we are waiting now. You see, it's active now. Okay. So now we go back to the other side, the headquarter here, and then show run again here. Okay, show run section, BGP. Okay, so now we go to config key. We want to copy this one here, router BGP 6503. Hit enter, and then we're going to say neighbor. The other tunnel IP should be .1.1 because this side is the 1.2. Remote should be .1.1, and then we're going to put the remote AS should be 65.0.0.7. Okay, so now show IP BGP summary. Just verify the BGP is up or not. Give a second. Come on. Come on. Oh, really? Come on. Oh, yeah. See, sometimes you just have to be patient a little bit, okay? Because this is just like we're using a GNS3, you know. We have a resource issue, you know, maybe slow down. So, okay, show IPBGP summary again. All right, so now we show IPBGP here, you see. Now we same thing again. We should have oh, this time, why I have a one path here? Do we have a, oh yeah, we have a two path, you see here. 152 is an MPLS, right? And then this is learning in here. There's a beautiful everything. 205. This 10 network from this one, and then okay. Let me see what else. Do we do we cover everything? Do we cover everything? Let me make it more clear. Okay. First, we go back to the. We are in the headquarter here, right? So the headquarter, it should be see the 10.205 network, right? That we're looking for. See here, show again IPBGP. We should be looking for the 10.205. Yeah, you see the 10.205. Now see we receive the 10.205 for the Chicago remote office is via the tunnel IP that is mean IPsec, okay, over the internet. And the second path is using the MPLS, okay. Now this router is prefer use the tunnel as the best path because you can see, okay, it's just shorter path, okay, so automatically, you see. But for now, we have to be adjust around later, okay. This is just for temporary. All right, so now we go back to the Chicago side here. So show IPBGP again. Do we see learning the 10 network, this headquarter? See, yeah, we learning to 2, 3, 10. That's beautiful. And also we learn it is from the tunnel, you see. And then same thing, if we lost the internet, the IPsec, we should be learning back from the MPLS. Beautiful. Okay, so now we have to prove it now. So can we ping? So for example, in here, can we ping? See, this is the call switch again. Okay, so from here, this is the switch here. So first thing the switch here, we verify, do we learn the 10.205 network, right? Show IPBGP in here. So make sure do we have the, yep, you see we're learning from 3.2 that it should be MPLS router, you see? Okay, so now go ahead, we can just try to test it now. Should be working or not. So we take with 10.05 and it should be 10.2. So we're going to using the source from the 10 dot, the VLAN 10 here. Okay, so let's see, let's try it. Oh, beautiful, look at that. Okay, so look at that. So now, you see, we all the way here, go to here, and then we crossing the tunnel. Okay, I mean like we like this, the tunnel. Okay, because this is going to be transparent. Actually, the path is crossing like this. Go back to here and then come to here and then over here the tunnel. Okay, so that is mean we buy, but once we in the VPN side to site. So this means we bypass the three path in here, right? But so it's just like a one path, but actually it's going to the all this router here. Okay. So now it's beautiful. You see, it's pink. So how about from the other side now, from here, right? So from here, so this is from the Chicago switch now. If I want to ping the VLAN 10 from here, so 10 dot 100 dot 10 dot 2, and then we're going to see using the source from 10 dot 205 dot 10 dot 2. Beautiful. Look at that. Now, how about if I do trace route? Can I do trace route in here? Dot 2, right? Using the source again. Say 10 dot 100 dot, no, 205 in here. 205 dot 10 dot 2. You see? Let's see, find out. We want to make sure this is go through the IPsec tunnel. Come on, come on, come on. Yeah, beautiful, beautiful. You see, beautiful. Okay. All right. Yep. You see? Yeah. See, when you see 172, perfect. That is the tunnel. Okay. Just a little bit slow. See, now is the MPLS router. Beautiful. You see, it's just only three paths in here. All right. So far so good. In this case, let's quick do some save it first. So everything's working now. So we save it first. Just we don't want to lose the configuration in here. Okay. We save it first here, and then we save it again. Let's just make sure we save everything. Okay. So now we already prove it, right? Everything it should be go to here. How about the internet? The one because here always go to the internet, right? But then the internet we should be route. It should be from the local, or we should go out directly to from the tunnel all the way back to the headquarters because we have a filter in here. Right? Maybe we have a like those kind of like proxy server. All right, because like everything, because we want to centralize the internet, because then we have like monitoring something the traffic. We have a proxy, so everything they go through have to be a monitoring, right? Okay, so now let's see if we able to go out to the internet. Now it's going to like IPsec tunnel like this, right? So go back to the Chicago switch again in here. Make sure the MPLS router here. Do we learn the default route? Show IP. Uh, yeah, BGP again. Here, hold on. Show IP BGP. Yeah, we have a default route. Same thing again. So we learn it the default route. Okay, you see, when you see 471.1.2.3.4, it should be from the Verizon here. Okay, so let's see if we can ping now from here, right? So if we ping, can we ping 10 dot? No, just ping Google, right? 8.8.8.8. You see? Can we ping 8.8.8? Oh, all right. So still not happy. Okay, she's still not happy. You see? The 8.8.8. Maybe we're missing something, or maybe say we should be using the source. It doesn't matter, right? We should be have the net. It should be 10.2 here. Wait a second. I should be ping from the switch here, Chicago switch here. All right, let's ping again. 8.8.8.8. Yeah, you see, correct, beautiful. You see, we ping 8.8.8. Okay, so internet is working. So the backbone, everything that uses VLAN, the network in here, can go out to the headquarters and also can go out to the internet. Okay. Uh, although we have the internet in here, but the same thing, but the traffic is go out to here. But I can explain to you how can we split the traffic, right, using the local internet inside the internet all the way back to the headquarters. All right. The reason is why, because in a scenario, in some case, right, we have those kind of, like, for example, we have like a window update. If you have like Windows Server or Windows system like that, if they want to update like window up like patch no window update something like that, because we it's taking all. Can you imagine in here if we have a 50 or we have a 20 computer, if they do it in the same time, they update the window update, right? And then they're going to talk to the Microsoft update server. If our network inside, if we don't have those kind of like a distribution, for what they call, I forgot. Should be Microsoft SMC, something like that. Is a management, so they can sync from the local window update instead go out to the internet. But in this case, we still have a small budget, right? We don't have, so we always allow the directly for the window machine or Windows Server directly go out to internet to do those kind of window update, right? So sometimes you have to think about. Sometimes maybe we have a small link in here, so small WAN link in here, right? Because we don't have a much budget, something like that, right? So maybe we have a 10 megabyte or maybe 20 megabyte link, something like that, and then maybe we have a 50 megabit, or maybe the internet is cheaper, right? Maybe the internet circuit is cheaper than MPLS, right? In here, maybe we have a one, or they give us like 1 gig link with the fiber because it's a logo, or that is wonderful, right? So, but sometimes it's okay, occasionally, okay, because sometimes that is like it depends individual, like home, Verizon or something like that. Contact, they maybe give it to you 1 gig with the monthly, it's a less payment, But then when they see it's the company, they charge the company is more than the home users, okay? But then still, maybe the local internet is cheaper than MPLS, okay? So maybe because this maybe say the MPLS in here we just only have a 10 megabyte, because maybe here is only have a 10 users, 10 people in here. We don't have to. So far, we just order for 10 megabyte in here. I mean, it's very slow down. Once you have in the same time, when you have all the computers synced to the Microsoft server in here, right? So for example, this is they have a one server in here. That is a problem. Okay, so that's why then they come to the network engineer. They same thing again. They open the instant ticket. They complain about the network slow from the remote office. Blah blah blah, something something like that. They keep complaining. They always blame on the network. Okay, so that's why really tough be a network guy, because they have to be always, you have to be deal always complain about. But sometimes the complaint is doesn't mean it's not working. It's working. It's just slow. Okay, because that's why we are the network engineer. So we have to be how we optimize, how we improve the traffic. You know what I mean? So that's why in here we have to be like isolate. We point it to local. Okay, so that is so far from the internet. We can perform it later. So right now we want to perform it is we make sure if we shut down here, it's the traffic should be go back to the MPLS, right? So that's why we have a full redundant. So let's go back to the this router again, MPLS router on the Chicago. So here, right? So now look at that. When we show IPBGP in here, you see, when we show IPBGP, as you can see, we still have see, this is the headquarter. We still have a two path, right? One is go to the VPN, and one is go to the MPLS, right? But now we on purpose now we want to shut down this VPN tunnel, right? So now we go back to again show IP interface brief, and then so we go back to the show config key. We're going to say tunnel 10. In here, we're going to shut it down in here. So we shut down this interface. Okay, so now we're going to be fail over now. You see, it's flapping the BGP. So now, when we show IPBGP summary again in here, you see, it's idle. Okay, because we shut it down on purpose. You see, the tunnel is not up. Right? When we show IP interface brief again in here, you see, it's not up. Okay, so now when you show IPBGP again, Now, how we learn now, you see, after we shut down, so everything, the path via the VPN is gone. Okay, it's been removing now because the BGP update in here is removed. Okay, it's not because the peer with the VPN got shut down. Is remove it now. It stay only one path. Go back to the MPLS. You see, this is the MPLS, right? So in this case, let's go back again to here now. Can we ping this time? You see, can we ping again about the VLAN 10 from here? So we ping again. Mm, oh, really? See, the failover is not working. Unbelievable. All right, all right. What else? So what else? What else? The issue in here? Why it was working fine. Once we fell over, it's not working. Hmm. Or maybe the other side that doesn't have update yet, right? Let's verify then. Show IPBGP in here, right? Oh, wait a second. Oh no, not this one in there. Should be here. Let's do trace route on just like just wonder, right, where we stop, right? So normally ping and trace route is a help for the troubleshooting, for basic, Let's 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 trace route 10.100, 10.2, and then we're going to see using the source from the 10 dot same thing VLAN 10 in here, right? So now we want to know where is stop. Okay, come on, hurry up. So sometimes we just run out of patience. Okay,
Mm-hmm.
so now, okay, go to MPLS router, and then it should be go to MPLS, right? It should be go to 152. Yes. Okay, go to 152. You see, beautiful. See, this is 152 here. All right, and it should be 152.1. We should see the that one. Oh, we don't see that one. Okay, we only go to dark 10. We only go to dark 10. We just only go to here. Anything issue here? Ah. Okay. Oh, but we miss. You see, but it's trace finish. You see, but trace finish. But then we have one in here. Maybe this is like we don't know what is caused here. It could be like a network delay or something like a hiccup. Okay, because normally if you cannot complete trace route, right, it give you like duck, something like that, right? But here, let's do one more time. Okay, do we have a delay or do we have a like a packet loss? Let's see. Because we want to see the result like this. You see, so complete. You see, without issue in between. This is funny. Why we have this one? Okay, okay, and then it's still thinking. It's still thinking. You see, the 10.1. The 10.1. Oh no, yeah, is it beautiful? You see, now 1 2. It just delayed. You see, it just delayed 3. Okay, yep, 3. And then what else? Yeah, go 3. So it's perfect. But why I cannot ping? Right? So why I cannot ping? You see here, 10.100, 10.2 here, source by here. So why I get timeout? Okay, so maybe we got something. The return traffic is something not right. Let's go back to the core switch here because that is the core switch here, the headquarter. Okay, so we show IPBGP first. Make sure we learn the 10.205. Okay, so now you see, now we learn the 10.205. Yep, by here. You see 10.52. That's beautiful, right? And then let's go back to the here, the MPLS router. So we go back to this is the MPLS router pair with the Verizon MPLS here, right? So we make sure this router here is learning the 10.205 from the MPLS, right? Let's go back to here. This is the router. You see, this is the router. So show IPBGP again. So we what? Do we everything is good? 1005. Yeah, see the 1005 is here. Yep, it's beautiful. You see, right? Show IP BGP summary. Do we have MPLS router is up? Yeah, we have up here. See, this is facing to the Verizon. Okay, yeah. So why it's not happy? Ping here. See, ping again. 10.205 now. This is from here now. 205.10.2, just like this, without the source on purpose. Oh, this side is working fine. You see, this side is working fine. Okay, so what is the trace here? If I trace here, 10.205.10.2. All right, so just like this. Okay, beautiful. You see, you go to the MPLS router, and then crossing the Verizon MPLS, and then arrive to the Chicago MPLS router, and then that is the backbone, the switch here. Right, so this is perfect. So, but how about the other side? But why the other side? Oh, let's see if we ping again from the specific source. Now, just make sure. Do we missing something again? So source is to be 10.100.10.2, right? Yeah, you see. And then same thing again, the trace route, we want to use the source 10.100. Oh, come on. .2. Yeah, this is perfect. You see? And then we can ping it again. It's beautiful. Then what happened here? Okay. You see, we ping from here now. Here's some issue, right? How about we ping from here? You see? So now in here we ping the 10. Hold on, what is the IP address? Oh, this is we are still in the switch. But the trace route is good. You see, the trace route is good. But then why we still have some issue? Why we cannot respond for the ping? Let's go back to the this router again here. So this is the MPL router here. This is the router here. This is the router. Okay. Show again IP interface brief. Okay. So this is the okay. So now I want to ping 10.100.10.2. I want to using the source with this IP. So I ping this one first from here. Are we able? Yeah. You see, this router. See, this router crossing the MPLS, I have no issue to ping the VLAN 10 in here. But why this switch in here? I can the trace route looks good, but why cannot ping? Let's try again. Maybe something that delayed. The BGP need to be updated. Okay, let's ping it again. See, let's find out again what IP address in here. Show IP interface brief. I want to ping. Yep. See, I want to ping and then ping 10.100.10.2. So we're going to be using the source, same the VLAN here. Right? Okay, we hit enter. Oh! it just the BGP didn't up. The other side didn't update. Maybe didn't update quickly. You know what I mean? So then that's why when you have a DR paperwork, that's why you have it depends, right? This is the demo from the GNS3, right? But in the production with the real device, and then you have to be once you everything successful, right? And then you have to be write it down.